After multiplying the reaction by n, the final equilibrium constant will be initial equilibrium constant raised to the power n, that coefficient from which it is multiplied. Now if the chemical reaction is reversed, final equilibrium constant will be reciprocal of initial equilibrium constant. If two reactions are added, then their equilibrium constant at final will be individual's product. Now if they are divided, simply final equilibrium constant will be Ka divided by Kb. Now let's move on to most important topic, that is Le Chatelier's principle. Le Chatelier's principle is one of the most important concepts from this chapter. What does Le Chatelier's principle state? Simply, if we provide certain states on the system, the chemical system tries to minimize the applied stress. It is not applicable for solid system or solid reaction, and it is only applicable for the system that are in equilibrium state. Let us understand about effect of concentration on equilibrium. Let us consider for this reaction, if we increase the concentration for A and B, that is, if reactant concentration is increased, equilibrium shift to reduce the reactant concentration, thus why the forward reaction is more favorable. Similarly, if we increase the concentration of C and D, if the product concentration is increased, equilibrium will shift to reduce the product concentration, that way backward reaction is favorable. If we decrease the concentration of reactant, equilibrium will shift to produce more reactant, that way backward reaction will be favorable, and similarly vice versa. Effect of pressure. As we know that PV equals nRT, that is, pressure is directly proportional to number of gaseous molecules. That is, change in pressure is directly proportional to change in number of gaseous molecules. For example, that del N that we calculated from this equation is equals 0. That is, changing pressure will not have any kind of significant amount of change in equilibrium constant. But if we increase the pressure for any other equilibrium, that will shift where it has less number of gaseous moles, and vice versa. More number of gaseous molecules on left hand side. If the pressure is increased, equilibrium will shift to reduce the pressure. The side of reaction with fewer gaseous mole will be more favorable. Now, effect of temperature. If del H equals 0, that is, effect of pressure will not have any kind of significant reaction. If del H is negative, that is, if the reaction is exothermic, and if the del H is positive, that means the reaction is